Okay. Today's December 6, 2011. We're on lesson 6.6. We're going to be dealing with exponential equations. Okay. Now this is the little formula they've given us. And what it is trying to find common bases or solving for exponents. So they've given us a formula that looks like this. A to the power of n is equal to a to the power of m if m is equal to n. Okay? Such that a is greater than 0 and a is not equal to 1. Okay. A has to be greater than 0 and could not equal 1 for this to be true. So, essentially what they're saying, let's call this our example. If 5 to the power of 2, 5 to the power of 2 is equal to 5 to the power of 2, as long as 2 is equal to 2. That makes sense, right? Pretty logical. Now, the reason they've shown us something like that is because now what they're going to be doing is they're going to be working with different different bases. We have to find a common base and then solve for variables in the exponents. So, this will be our first example. Example 1. 5 at x is equal to 5 to the power of 6. What does x equal? You guys are geniuses. All right. Let's do 125. All right. Okay. Our next example. Let's say 2 at x. 2 at x is equal to the number 32. Okay? So in a question like this, right now we don't have what we had in the first one. We had a common base and it was already set up with exponents. Now what I have is a base and a variable is an exponent and I have a whole number. I need to change 32 into the base of 2. Okay? I need to change 32 into the base of 2. So, can we think of 2 as a power? What power would be equal to 32 in this case? Let's go through some options. So, let's say 2 to the power of 4. 16 doesn't work? Good. 2 to the power of 5 is equal to 32. So what I'm going to be doing is we're going to change the 32. 2 at x is equal to 2 to the power of 5. Okay? Now that we have that, we can say that x is equal to 5. So I needed to change 32 into a base. Okay? The next question, I have base 7 to the power of 3x minus 4. On the other side of my equal sign, I have 49. So again, my goal here is to try to make this whole number into a base and an exponent. We need to have the same base as before. So a lot of these is going to be recognizing squared numbers, numbers to the power of 3, 4. So I have the number 7. I can use trial and error to figure out how to turn 7 into a base that would be equal to 49. So in other words, 7 to the power of 1 is 7. This is our trial and error method. Let's do 7 to the power of 2, 49. Right away we got it. So what that's saying is, we just discovered on that calculator that 7 to the power of 2 is equal to 49. So I'm going to replace 49 with 7 to the power of 2. So we end up with 7 3x minus 4 is equal to 7 to the power of 2. Okay. Now that we have that, essentially we can drop the base, 7 and 7, from this equation. Think of them as being irrelevant or they cancel each other out. So now the equation reads 3x minus 4 is equal to 2. What we did there is we just took the exponents and we created an equation out of them. Now, this is something we've been used to doing. We have to isolate for x. So I'm going to move 4 to the other side of the equation. We're going to get 3x is equal to 2 plus 4 is 6. And then I have to divide both sides of the equation by 3 in order to isolate x. X is equal to 2. Okay. Now, we can always check this by plugging that 2 back into our equation. Okay? Essentially, when we go to check this, we'll call this the check here. Put a line across. We have 7 to the power of 3 times, our answer above was 2. So we're going to plug 2 in for the x variable, minus 4. Is equal to 49. So I'm going to solve my exponents. 3 times 2 is 6. So I have 7 to the power of 6 minus 4 equals 49. 6 minus 4 is 2. 7 to the power of 2 is 49. And we know 7 to the power of 2 is 49. So 49 is equal to 49. So our check worked. We figured out that x was the variable we were looking for. Our fourth example. So it's a little different from what we were looking at before. We have base 3 with an equation as our exponent. And on the right side of the question, we have 27 to the power of x. Now we're trying to solve for what x is in this case. So again, I need to make sure that the bases are the same. So again, we can use our trial and error method to solve this. So 3 to the power of what will give us 27? So 3 to the power of 1, we know that's going to be 3. In fact, any number to the power of 1 is going to be what we start with. So we probably don't have to use that one when we go through trial and error. 3 to the power of 2 is 9, not what we're looking for. 3 to the power of 3 is 27. Perfect. So what we just discovered on the calculator was that 3 to the power of 3 was equal to 27. So I'm going to replace 27 with 3 to the power of 3. So we're going to get 3 to the power of 5x plus 8 is equal to, now remember this rule, okay? 3 to the power of 3 to the x. Does anyone remember an exponent rule here? This is a power of a power. Yes, so we have to multiply those two together. So we can't just drop the 3's yet. We've got to multiply the 2 together. So we get 3 to the power of 5x plus 8 is equal to 3. We multiply our two exponents to the power of 3x. Now that we've done that, just like in the previous question, we're going to drop our bases. So the 3 and the 3 are going to go away. We're going to drop the base. I thought that was funny. 3x, 5x plus 8 is equal to 3x. Okay? Now we can work with this like a linear equation. I'm going to move 5x to the right side of the equation. I want to get all of my variables with x on one side. So it will become negative 5x on this side. So we'll get 8 is equal to 3x minus 5x, negative 2x. And then to isolate x, we divide by negative 2 both sides. We get negative 4 is equal to x. Okay? And in our check, we'd actually have to plug that value into both of the x variables. So let's check. Now our answer was negative 4. So the question originally read 3 to the power of 5. This was our x times x plus 8 is equal to 27 to the power of our x. So we'll plug in our x value, which is negative 4, into both of these. Okay. Now, because there is an x on both sides of the equation, I'm actually going to have to simplify both sides of the equation to check. So we get 3 to the power of negative 20 plus 8 is equal to 27 to the power of negative 4. Okay? 3 to the power of negative 12 is equal to 27 to the power of negative 4. Now, it's kind of hard to tell if these are both the same. I could type it both into a calculator, but I want to prove it here. So I'm going to use my rule from above. If you guys remember, we discovered that 3 to the power of 3 is equal to 27. So I'm going to replace 27 again with 3 to the power of 3. I want to make sure the bases are the same. So 3 to the power of negative 12 is equal to 3 to the power of 3 times negative 4. Again, we use our exponent rule, a power of a power. 3 to the power of negative 12 is equal to, when we multiply those exponents, 3 to the power of negative 12. So even in our checking, we're still using some of the rules from above. It's a good practice to go through and check this, make sure we got the right answer on the test, plus it gives us extra practice with what we're doing. Okay, we have another exponent question. We have a base with almost like an equation as the exponent, and a different base with another equation as the exponent. The key to these is I want you guys to always remember we need to find the same base. That's our goal in all of these. So, since this is our lower number, just like we've been using before, we had 3 was the lower number of 27. 2 was the lower number out of 32. We have 2 and 4. I want to change 4 into a base of 2. So I want to change 4 into some base of 2 and an exponent. Off the top of your head, 2 to the power of what is 4? 2. Good. Glad you know that one. So because we know 2 to the power of 2 is 4, we're going to replace 4 with 2 to the power of 2. We're going to get 2 to the power of 2 minus 5 is equal to 2 to the power of 2 times this exponent, 3x minus 1. Okay? It's the power of a power rule again. We need to multiply those exponents. So in other words, we get a question that says 2 to the power of 2x minus 5 is equal to, I'm not sure why I put the equal signs. 2 to the power of 2 times 3x minus 1. So this was the very important step here. This 2 needs to be multiplied by everything that was there before. We have to use our distributive property again. Before I use distributive property, I'm going to get rid of the bases. They're now finally the same. So we're going to drop our base of 2. And our question reads 2 times x minus 5 is equal to 2 times 3x minus 1. Okay. We can distribute the 2 in. Technically a faster way we could do this. Does anyone know a quick way to get rid of those 2's? Divide what? Yes, that's right. Okay. Because each side of this equation is being multiplied by 2 here, if I divide both sides of the equation by 2, I can drop both those 2 off. Now, if you don't understand that idea, you can use distributive property. So we'll show both methods. Okay, on the right side of the equation, what I'm going to do is I'm going to divide both sides of the equation by 2 like we said. So if I divide both sides of the equation by 2, the 2's will all cancel each other out. I'll be left with a simpler equation, x minus 5 is equal to 3x plus 1. Now on the other side, what we could have done is distributed the 2 into the brackets. Either method's going to work. One will take a little longer. So 2 times x is 2x. 2 times negative 5 is negative 10. 2 times 3x is 6x. 2 times negative 1 is negative 2. Okay. I'm going to move all the x's to one side of the equation. So I'm going to move my 3x over here. And I'm going to move all my constants to the other side. So I'm going to move my negative 5 to the right. So we'll get x minus 3x is equal to 1. Now this negative 5 becomes plus 5. X minus 3x is negative 2x is equal to 1 plus 5 is 6. We divide both sides by negative 2. We're going to get x is equal to negative 3. We'll do the exact same thing on the other side. I'll do it the reverse. We'll move the x to this side and the constant to the other. So we have negative 10. That 2 becomes plus 2 is equal to 6x minus 2x. Negative 10 plus 2 is negative 8 is equal to 4x. And when we divide both sides by 4, x is equal, oh, what happened there? Oh, I switched it. Sorry, my fault. So this is supposed to say subtract. Hey, it's good that I did both methods. I realized that I had made a mistake. No, I made the mistake. What did I have written here? Minus 3. Now, negative 1 plus 5. Okay, that makes sense. Then we get 4 divided by negative 2 is negative 2, which is the same answer we got on the other side. Hey, it's a good thing we did that. Figured out our mistake. So both methods will get you the same answer.